Considering how important water is to our body, they contain about 70% of the human body. So we need to study water and how many things interact with water. So in this video, we are going to be looking at how acids and base interact with water. Now, when you say acid and base, we have different definitions. We are going to be looking at these three definitions. The Arrhenius definition. The Arrhenius definition is saying that acids are proton donor. Why it is saying that base are hydroxide ion donor. Normally, when you have a pure water, that pure water contains equal amount of proton and hydroxide ion. Now, when you donate proton to this water, what happens is that you are going to have more proton and less hydroxyl ion, because before you have something equal and now you have more proton added to that water. So you have more of the proton, you have less of the hydroxide ion. So this is the case for acid. For base, we call it hydroxide ion donor. So it means that at first you have equal amount of hydrogen plus and OH minus. So what happens is that when you add more of this to it, it means this will increase and this is still the same. So this is more than this. So let's say this is small and this is many. So that is the case for a base. All we are just trying to say is that in an acid, H plus is always more compared with hydroxide ion, and in a base, H plus is always less compared with hydroxide ion. Now, let's move to the second definition. A Bronsted Lowry acid is defined as a proton donor, just like we have it in the case of Arrhenius acid. So, Bronsted Lowry acid is a proton donor, and then a Bronsted Lowry base is a proton acceptor. So what this means is that at first we have equal number of hydrogen ion and hydroxide ion. Now you add a substance to it, and that substance is donating proton. So when the substance is added, the change we observe is that we have more proton compared to hydroxide ion. So that substance is called an acid. But when a base is added to the same solution, we are going to have a proton acceptor. Let's just denote it with this. At the end of the day, what this proton acceptor does is that it's attached to the proton. This with the proton, this with the proton. So at the end of the day, what do we have? We find out that more proton are not free. What we now have is more hydroxide ion. So following Bronsted Lowry definition, we could still agree that when acids are added, we are going to have more proton in the solution compared to hydroxide ion, and when base are added, we are going to have less proton in the solution compared to hydroxide ion, or we say more hydroxide ion compared to proton. So that's it. And the last definition we'll be taking is Lewis' definition of acid and base. According to Lewis, acid are lone pair acceptor, while base are lone pair donor. So looking at water, water have oxygen, and oxygen is binded to hydrogen that makes up water. So let's look at this compound. This is a carbocation. If this is binding to this, this here, possessing a lone pair itself, is acting as a base here, and this that is accepting this lone pair is acting as Lewis acid. At the end of the day, you are going to be having something like this. Because this is not stable, one of these bonds will break and we are going to have this. So at the end of the day, what we have is an extra proton. Now let's go to the base, lone pair donor. Imagine something is donating a lone pair. Let's call it B. In a solution where you have H plus, you have OH minus, and you have H2O. What do you think would be the most favored substance that it will bind to? If I were you, I would say this, because this is having a lone pair and this is having a proton, so it's a perfect match. So what we have here is this bind to this, and then the number of proton that we have in the solution decreases and this remain unchanged. So because this is decreasing, this will become more than this. So we are going to have more of this and then less of this. So just like every other acid, the Arrhenius acid and Bronsted Lowry acid, Lewis acid would also lead to the increment of proton, and Lewis base would lead to the increment of hydroxide ion. So this is the basis for pH, which we are going to be treating in the next class. So practice this question, it would help you a lot, and thanks for watching.